In Java, we have another tool for writing thread-safe code, but without the overhead of synchronization. It's the volatile keyword. It solves the visibility problem, but not the race condition. So it doesn't prevent two threads simultaneously modifying some data. Instead, it ensures that if one thread changes some data, other threads can see the changes. Let me show you a real example. So here in the download status class, let's add a new field. Private Boolean is done. With this flag, we can tell if we have downloaded all the files or not. Now let's create a getter and a setter for this field. So Alt and Enter, create getter and setter. Now, I prefer to rename the setter to done and remove this parameter. So here we explicitly set this field to true. We're essentially sending the done message to this object and let this object take care of setting its status. Now, in our demo class, we want to create two threads. One thread simulates downloading a file, and the other checks to see if the download is finished. When the download is finished, we want to report something to the user. So first, let's create a download status object, download status. Now we create our first thread. So thread 1, we set this to a new thread with a new instance of our download file task and pass our status object. Now, back to our download file task. I want to run this loop for 1 million times because I don't want this to finish so quickly. Now, after this loop, we're going to call status.done. We're sending the done message to our status object. Now, back to our demo class, we create our second thread. So var thread 2, we create a new thread. Now this time I want to pass a lambda expression to represent a runnable object. We could also create a separate class that implements the runnable interface, but I want to change things up for a little bit here. So we pass a lambda expression for the runnable interface. That's basically a function with no parameters that returns void. Now, in the body of this lambda, we should continuously ask the status object if it's done or not. So we had a while loop. We ask the status object, are you done? As long as it's not done, we're going to wait. So here we have a while loop with an empty body. We're just waiting. The moment our download is finished, we're going to print status.getTotalBytes. Now let's start both these threads. So thread 1, .start, and thread 2, .start. Now run our program. So thread 1 started and finished, but thread 2 is still going. In fact, it's going to go forever. Why is this happening? Well, let me stop the program first. Back to our download status class. Earlier, we used the synchronize keyword in 2 places in this class. So how come the synchronize keyword didn't help us here? Well, the synchronize keyword is not a silver bullet. In this particular case, we want to make sure that only one thread at a time can update this field. But here we're dealing with another field. These are 2 separate fields. Now, if you want to solve the problem in this demo, we should mark these 2 methods as synchronize. Now, I told you that this is a bad practice. You should prefer to use the synchronize block as opposed to declaring an entire method synchronize. But let's not worry about the problem with this approach and see if the synchronize keyword solves the problem. Now, run the program. So thread 1 started, it finished, thread 2 got notified and printed the total number of bytes. So the problem is fixed. Now, back to our demo class. Even though the synchronize keyword solved this problem, it can cause a lot of overhead because in this while loop, we're constantly calling the isDone method. While we're calling this method, no other threads can do anything else with this status object. They cannot call any other methods in this object. So all these method calls will run in sequence. Let me show you a better way. So back to our download status, let's remove the synchronize keyword. Back to the original problem. When we run this program, the second thread waits indefinitely because it doesn't see the change to the isDone field. This is the visibility problem. So one thread changes some data, the other thread cannot see the change. But why does this happen? Well, the Java virtual machine makes some optimizations under the hood to make our code run faster. One of these optimizations is caching values. So let's say we have an integer field with the value 1. This value is stored in the main memory or RAM. Now, we have two threads running by two different CPU cores. Each CPU has a cache, which is a small amount of memory available locally in that CPU. Reading the data from the cache is faster because the data is closer to the CPU, so it doesn't have to travel far. It doesn't have to travel between the CPU and the main memory, okay? Now, this is what happens. Two threads read the value of a field and store it locally. Now, the first thread changes its value, but this change is only local to this thread, so the second thread doesn't see the change. Even if it writes the change back in the memory, the second thread doesn't see the change because it already has the value of this field in its cache. This is a visibility problem. To solve this problem without the overhead of synchronization, we can declare this field as volatile. So we type volatile. Volatile means unstable. So we're telling the Java virtual machine, hey, this field is unstable. It may change. So don't rely on the value stored in the cache. Always read it from the main memory. And that means if another thread updates the value of this field, the change will be immediately written to the main memory. Now let's run a program and make sure the problem is solved. So run. There you go. So the volatile keyword guarantees that the changes to a field is visible across threads.